So continuing with our work with angles and triangles, now we're going to look at the angle properties in triangles. Okay, so we've already looked at two of them. And those two rules are that straight angles are supplementary, which means they have to add to, hopefully everyone said 180 degrees. Okay, so if I told you that this was 140 degrees, then this angle here would have to be 40 degrees. 180 minus 140 would give you 40 degrees. Okay, so if you have any sort of angle, it can look like anything, A and B, A plus B has to equal 180. Okay, and then the interior angles of a triangle must add to 180 degrees. Exactly 180 degrees. Okay, so if we say that this is an isosceles triangle, so we have A, B, C. What do we know about angles A and C? They are equal to each other. So angle A plus angle B plus angle C equals 180 degrees. And then this second triangle here, we'll call this DEF. This is what kind of triangle? This is a right angle triangle. So we know that angle E right away is 90 degrees, but we don't need to think about that right now. We just know that angle D plus angle E plus angle F equals 180 degrees. Okay, so let's look at the relation and an exterior angle of a triangle. So an exterior angle is any angle that's outside the triangle and adjacent or beside an interior angle. Okay, so if we look here, here's our line that extends out. Okay, the interior angles in this triangle would be angle A, angle B, and angle C. Those are interior. Okay, and here's your exterior angle. Okay, and we know that there are three interior angles and they're located at the vertex of the triangle, so each vertex. So you have, so B, A, and C are vertices is the plural, or a vertex. So two angles of a triangle that do not share the same vertex as the exterior angle are called non-adjacent, so not beside each other, interior angles, or not beside the exterior angle. So if we draw our triangle again, we have not B, A, B, and C. Okay, and let's get, because there was an exterior angle, there's C. So A and B are your non-adjacent interior angles because they are not beside the exterior angle. C is. Okay, so two things are true about this triangle. So if we know that this is 55 degrees, what would our exterior angle be? So look at where C and D are located. So C and our exterior angle, they are on a line. So we know that they have to equal to 180 degrees. So our exterior angle will equal 180 degrees minus angle C, which is 180 degrees minus 55. So our exterior angle equals 100. And we can also name this angle DCA. Okay, so it would start at D, C is where the angle is, and then A. Okay, so that would be angle DCA. And then we also know that all three interior angles must add up to 180 degrees. So we can't find out the exact values of A and B, but we know that angle A plus angle B plus angle C equals 180 degrees. So angle A plus angle B must equal 180 minus 125 degrees. So, 55 degrees, because we want angle C. So angle A plus angle B equals 125 degrees. We don't know what equals what, but that would be their total amount. So those are the two things that we can tell just with one angle in this triangle. So the exterior angle, so DCA equals the sum of the non-adjacent interior triangles, or angles. Okay, and these are all just assumptions that we can work with to make our lives a little bit easier. So let's do an example. So if we want to find the missing angles, I'll give you, here I will do 68 degrees, and here I'll give you 49 degrees. Okay, and then here I'll give you 114 degrees and 64 degrees. Okay, so we're going to work through the first example together, and then the second example, I want you to pause the video, try to work through it yourself, and then come back and check your answer. So for this one, to find the exterior angle, it would equal what? So if I want to find this angle here, we do 180 degrees minus angle C. So 180 degrees minus 63 degrees, and that would give me 68 degrees. 112 degrees. So this is 112. Then I know that angle A and angle B will equal the exterior angle, so I can find angle B two ways. So for angle B, I can either do 180 minus 68 minus 49, or I can do angle B equals 112 degrees minus 49 degrees. And we will get that that equals 63 degrees, no matter how we found it out. Okay, so we can find it out using the sum of angles in a triangle, or the fact that exterior angles equal the sum of non-adjacent interior angles. Okay, so now pause the video, try to work out the second example, then come back and see if your answer is correct. Okay, so you'll have found, hopefully, that angle A is 55 degrees, and angle C is 61 degrees. Okay, and if you found it using, say, the sum of the angles in a triangle, that's fine. You just have to be able to find it and prove what you've done. So find all the missing angles. So let's suppose that we are given, and let's first label all these. So A, B, C, D, and E. Okay, so suppose you're given that this angle equals 128 degrees, and this angle equals 51 degrees. And then we'll also say that this angle equals 77 degrees. Okay, so what can we do here? So let's say we want to find this angle in the triangle, BDC. So angle BDC equals what? How can we find that angle in the triangle? Hopefully you see that we have the two other angles, so we can just do angle, or 180 degrees minus 51 degrees minus 77 degrees, and you'll get that that is 52 degrees. So that's 52 degrees. Okay, so then we can see that we could have also found, because these are on a line, okay, so it could have been 180 minus 128. And then we can look at this and using what we know. So if we know that this is 52 degrees and this is also on a line, angle D will equal 180 degrees minus 52 degrees, so that will equal 128 degrees. Okay, and then if we look at this, we'll see that this is equal to that. So those are vertically opposite or supplementary angles. So supplementary with the 52, vertically opposite with the other 128. And then that means that this angle here would be 52 degrees. And again, we can say that it's supplementary right there with that 128, or it's vertically opposite with the 52. So consider the diagram below and prove that angle A equals 30. So I'm just going to draw the diagram for you. Okay, so if we look at our diagram, we have two triangles attached to each other. We have, so angle, or triangle BCD is what kind of triangle? So triangle BCD is an equilateral triangle. And angle, or triangle ABC is isosceles. Okay, so because BCD is an equilateral triangle, we know that all of its angles equal 60 degrees because they all have to be equal to each other. And then to find, we can find this angle here, angle ACB will equal 120 degrees because it's 180 degrees minus 60 degrees because angle ACB and BCD are supplementary. Okay, and then this angle here, ACB, counts as a exterior angle to angle BCD. Okay, so we want to prove that angle A is 30 degrees. So here, if we have these angles here, now if we have that triangle ABC is an isosceles triangle, and we know one of the angles, isosceles triangles mean that the angles opposite the equal sides, so here are your equal sides, and here are your angles that are opposite them, are equal. Okay, so to find angle A equals what? 120, okay, we'll say this another way. Angle A plus angle B plus 120 degrees equals 180 degrees. And we know that angle A equals angle B. So we can say this as 2 of angle A equal 180 degrees minus 120 degrees. So 2 of angle A equals 60 degrees. To get angle A by itself, we divide both sides by 2, and then angle A equals 30 degrees. So we have proven that angle A equals 30 degrees. Okay, so we're going to do one last example and then stop from here, stop for the lesson. Let's try example number 4. So consider the diagram below. Determine all missing angles below. Are the lines A, B, and CD parallel lines? Justify your answer. So I'm just going to fill this out for you. Okay, so if we're given these 3 angles, angle ABC, BCD, and let's say DC, I'll say that this is E over here. Let's find out if these are parallel lines. So first let's find our missing angles. Okay, so let's find angle A. So angle A will equal 180 degrees minus 62 minus 71, because the sum of the interior angles of a triangle equal 180 degrees. And this will give me 47 degrees. So 47 degrees. Okay. And then how would we find out this angle in here? So let's look at what that angle is on. So if you look, this angle is on a line with these other 2 angles. So this angle here and this angle here. But even though there's 3 and we've been working with 2, they still have to equal 180 degrees. So angle BCD equals 180 degrees minus 71 degrees minus 47 degrees, and that equals 62 degrees. So up there is 62 degrees. Okay, so we found all the angles, and now we want to find if AB and CD, so AB and CD are parallel. Okay, so let's look for rules. So we have angle, things that are equal. Angle ABC equals angle BCD, and they both equal 62 degrees. And this would make them what? It looks like a Z shape to me, a Z shape. So they would be alternate interior angles. Okay. We could also look at the fact that angle BAC is equal to angle DCE. And these ones would be corresponding angles. So because of these 2 reasons, even though you only need one, I just wanted to show you both, we know that AB is parallel to CD. Okay, so go through the video. I would recommend if you do it sooner in the spring break, then refresh yourself before you come back. I will not be collecting that basic geometry work, and I'll post the key right away. I will be collecting the worksheet 2.2 for marks. So bring that in on Tuesday when you come. So Tuesday, April 2nd is our first class back. We will have a very small quiz to refresh what you learned. We'll do a review, and then we'll start the quiz at 9:30. So please email me if you have questions. I will be checking my email periodically over break, and have a good spring break.